Hi, my name is Dennis, and today I'll walk you through some of the basic commands of Python. So the first thing we need to do is to make sure that Python is actually installed in your system. So maybe your system already comes pre-installed with Python. If not, then you can go to python.org and download a version of Python. Alternatively, have a look at my previous video on how to install Python with Conda. So once Python has been installed, head on over to the terminal. And as we can see here, I'm using Conda in the environment called ML. And if we just invoke Python here, then we get into the interactive shell of Python called the REPL, also stands for read, evaluate, print, and loop. And here we can basically do everything you can do in Python. So Python also works as a simple calculator. We can say a equal 2, b equal 3, and then we can say a plus b, for instance. But instead of writing everything down here in the shell, what I will show instead is how to make use of Jupyter Notebook. So the first thing we need to do is to install Jupyter. So as we can see here, Jupyter had already been installed in my system. Now we just need to change the directory to where we store our notebooks, and then invoke Jupyter Notebook. So Jupyter Notebook will open in a browser as an interface like this here. So I'll just go to Python Introduction and Python Basics. So a Python notebook consists of individual cells. So if you double click a cell, you'll see the raw context of it. So here, this cell here, see up here in the top, that this cell contains markdown. To evaluate what's in a cell, either click the run button up here, or alternatively press Shift Enter. And once again, this here is also a markdown box, and the same for the next one here. So here in the top, just some basic information for people new to Python. So Python is a dynamically typed language, and in comparison to Java, which is statically typed, this mainly has an influence on the way we define variables. So in a statically typed language like C or Java, a variable is bound to its type and object, whereas in dynamically typed languages, just like Python, a variable is only bound to an object. And also there is no compilation needed in dynamically typed languages such as Python. Instead, what we need is an interpreter which interprets the code in runtime. So we already looked at the REPL, which is this read, evaluate, print, and loop. And now we'll go through step by step basic examples of Python and slowly build up upon the concepts from simple variables to functions to loops. So in the beginning here, just as in the REPL, we can also use Python here in the notebook as a simple calculator. So it could be like 3 times 5 times 3. Or you could have 5 powered by 2. Alternatively, we can also import math, and with math we can then use math.power, and also has the power functionality. So math also has functionalities such as pi and cosine and sinus and so on. So as you might have noticed, like the output is shown here, which is the evaluation of the cell, which just outputs the last line of the cell. So in case that we had a equal 1 and b equal 2, then in fact we will not have any output, as the last line of the cell is just an assignment. Instead, if we just say here a plus b, then we will have an evaluation of a plus b, which is not assigned to another variable, but given as the output here. So Python has 3 numerical types: the int, the float, and a complex. So let's start out with how we define a variable to be an integer. It's simply done like this. You just write x equal 1, so there's no decimation of this number. And now we can then output this together with what is the type of x. So here the value and the type. Okay, so what if x instead is 2.8, for instance? then we define a float. And likewise, then the third possibility is a complex number. Then you will have like some real number plus the complex number. You can also easily convert variables. So if you had a double here, let's type float. Now we can convert this float variable into an integer. So these are the three basic variables of Python. Okay, so let's continue on to strings. So either strings can be defined by using a single quote, or they can be defined by the use of double quote. And now to combine these, we can simply just take my string 1 plus my string 2. And now to print this variable, like obviously here in Jupyter, we can just, like, it will just output the last line. So here we'll have pattern recognition. Maybe let's make a space here. Alternatively, when you're writing a program, often you would use the print command. So how do you actually print a string? The string is in this way. You can just make a comma in between. That would work. So let's look at different ways we can combine strings. So as you see, there are plenty of different ways to print simple strings into the terminal. If we want to print example integers, we can also easily do that, and they are automatically converted into strings. Alternatively, you could also surround this one here by string, then you're manually converting the integer to a string first, and then it's printed. But also if not, then the print function will automatically find it out. And lastly, here you can also define strings which contains single quotes or double quotes. So one way is if you want single quotes, then the outer is double quote. So we can have here some quotes. Maybe just remove this. Alternatively, you could swap this here around. If you want the double quotes. And lastly, if you want to both use single quotes and double quotes, you can have 3 single quotes, start and end with 3 single quotes, and then you can have some quotes here. The next part we'll talk about is Python operators, symbol, and, or, modulus, addition, and for comprehensive list, I'll refer you to the W3 School website. So this here would be, for instance, how does it look like if we want to say that 1 equals 1 and 2 equals 3. So obviously, like this here will end up false, but here we see how we can use a simple AND operator. So it could also be OR, so the first statement here should be true and the second one false, which will end up being true in the end. Or also, for instance, the modulus, so we could have 3 modulus 2, so we have 1 in the remainder. So the next concept is arrays, and in general there are 4 different types of arrays, and it's a good thing to have a good feeling about what type to use where. So lists are ordered and changeable and allows duplicates. Tuples are ordered and unchangeable and allows duplicates. Sets are unordered and changeable and does not allow duplicates. Finally, we have dictionaries, which is defined by a key and a value, and these are unordered and changeable and indexed and allows no duplicates. So let's start out with a list example. So we have this list, and we define lists by the square brackets here. So let's just have a list of strings: apple, banana, cherry. So then we can print the list down here in the bottom. Okay, so the list is defined. We have 3 items in it. So now, what if we append an item to this list? We can just append 2. So now it's not a list of strings only, but it also contains an integer. And we could append also a second banana. So we see that it allows to have multiple items of the same value. And if we just are interested in the first value, it's simply just to look up, take the index, square brackets here, and define what index you want. We can also easily change the items in a list. For instance, say that this list item 0 should instead be a carrot. And obviously we would like to get the output, so suddenly the list has a carrot instead of an apple as the first item. Then another handy thing is also that you can look at, okay, how many items do I have in my list? So in this case we have 5 items in the list. Then we can easily remove items from the list by invoking the pop command. So in this case we'll take out the last item of the list. So the list after popping this will contain everything except of the last item. So in this way we can iteratively pop items from the list. Okay, so the next concept are tuples. So tuples are defined by a single parenthesis. So again, we can have a tuple this time of fruits, apple, banana, cherry, banana, and then we can print this. And again, we see that tuples allows for duplicates. So we have 2 times banana. And tuples are also indexed. We can get the first item of the tuple in the same way as with list, just by having the square brackets and inserting the index. But in comparison to list, we cannot update items in a tuple. So if we want to update here, then it says that tuples does not support item assignment. And the same goes for append or add. Simply, once a tuple is defined, you cannot add or remove items from it. So the third concept is sets. So here if we define a set, and now we use the curly brackets here. So if we have again apple, banana, cherry, banana, and we print this set here. Now we see that banana only appears 1 time in this set. So this is because that sets do not allow for duplicates. So how to add things to sets? So we can say this set.add. So maybe we want to add a carrot. So we can add things to sets. Like adding, we can also remove items. So we can discard banana. And now there's no banana in this set. So the fourth and final array type is dictionaries. So maybe we have this dictionary 1. And as mentioned, this is defined by a key and a value. So here maybe we have, okay, this is brand, Ford, and then a comma, so we can have multiple values in here. Model, Mustang, so make this here. So this dict 1, and we need a comma here. So now we see the full dictionary. So what we can now do is we can look at all the keys in this dictionary. So all the keys will be brand, model, year, and we can look at all the values of this dictionary. So Ford, Mustang, 64. We can also change items in this dictionary by saying, for instance, that the year should suddenly be a newer model. It could be 2018. And we can also add items in the same way. So this dict by saying that we have a color, and maybe the color is red. Finally, you can use the command items, which will then give you back a dictionary item. And what we see here is that it consists of a tuple, like a list of tuples. So dictionaries, they are also often used together with other array types like lists. So we could quickly just add a second dictionary, and now what we'll do is now we have a dictionary list. So we could have a list here of this dictionary 1 and this dictionary 2 dictionary list. So what we see here as a dictionary list is in fact the same format as the JSON format. Okay, so let's continue to something very basic in Python, namely how we write the code. And the concept here is that either we use 4 spaces or 1 tab. So it could be that we define a function like this here, but it somehow needs, like a function needs an indentation and some kind of code in here in the function. So what we could put in here is a pass, which is just a command that does nothing. Then suddenly this function is fine. So we'll get back to functions further down, but just for now, just so you know that you should either have 4 spaces or 1 tab. So it looks like here that the notebook actually converts 1 tab into 4 spaces, but it all depends on the IDE that you're using if it actually converts tabs to spaces. So the next concept is conditions. So here we could have a simple variable a, set it to 33, so this will be an integer. Then we can say if a is above some value, then we say, okay, a is over 30. We could have an else if condition. What if it's exactly 30? Then we can print that a is equal to 30. Otherwise, we can have the wildcard if something else happens. So in this way, we would know that it would be less than 30. So in this case, okay, a is over 30. If it's 30, then it's equal to, and if it's less than, then it's also written that it's less than 30. So the next concept is loops, and there are a lot of different ways to define loops in Python. So to start out with the while loop. So while I below 6, for instance, then we can print I, and then in the last line here we can increase the variable I with 1. So what we'll see here is just that the numbers from 1 to 5 is written. If we have some array type, for instance, a list here, so again we could use our list of fruits, then an easy way to loop over this is just to use for x in fruits, and then each item from fruits will be assigned the variable x. And now we can then print x, so in this way we loop over all the items in the list. As an extension to this, you can use a comma x in enumerate. So now an integer will be assigned to each of the items in the fruits list. Another very handy functionality is the use of range. So in this way we can say that, well, at first we can just try to define in range 5, print x. We could also say that we want another range, like from 2 to 10. Okay, and maybe we instead of 1, which is default value, we would like instead of 2. So range comes in very handy quite a lot of times, as you can see. And now we finally come to functions. So I already briefly mentioned how we define a function. So it starts with def and then the name of the function. So we could have an add function here, which takes a, and then it takes another variable b, and it simply just returns a plus b. And now we can have add 2 plus 5. So this will give 7. Alternatively, you can also define default values for the parameters. So it could be that the default value for b would be 2. So in this way here, then we can add just 2, and we know that b will be assigned the default value 2. So in Python, we're not limited to only only having one variable. So we could have another function which is def myfunc a comma b, and it might return a minus b and a power to 2 and b power to 2, for instance. So this way we'll send 2 variables and we'll be returned 3 variables. So another newer functionality of Python is the use of type hints. So if again we define our function add here, then we can in fact say that the variable a is an integer and the variable b should be an integer, and as the output of this function, this will be an integer. And now we can just return a plus b. But the type in functionality might not work as you expect. So we could have add 7.5, so add 7 and 5. But what if suddenly we add doubles, so 7, 5 and 5, 5, then it still adds the 2 numbers and returns a double. So we can check the return type here of the add function, and this is a float. And we can even try what happens if we have 2 strings that are sent to the function, then it just concatenates the 2. So this is also the reason about the name type hints. It's only a hint about what the type could be, but it's not enforced during runtime. Let's quickly look at another example where we have a multiplication function, a int, b, int, and what we return is also an integer. So in this case, a multiply by b, then we see that if we multiply 7 and 5, we get a good value back, but the function is not well defined for multiplying strings. Then we'll get an error that it cannot multiply sequences of type strings. So now we see an error being thrown here, so a good thing will also be looking into how can I actually handle these errors during runtime. There the concepts of try, except, and except come in, and for instance we can try to print that 1 divided by 0, and then we can have an exception if there is a 0 division error, and then we can print that dividing by 0 is not allowed. Oops, and we have to like this here. If you do not know exactly what error to expect, you could also just remove here and just have a generic error being thrown. And it could also be that you yourself want to raise the error if something happens. So we could have a divide function here, a comma b. Then we could say if b equals 0, then we can raise that there is a 0 division error. If not, then we just return a divide by b. Then we can call divide and 2, or set 0 here. And now this function raises a 0 division error. Obviously how we should handle this is like in the above example, so we will try to divide 1, 0, and then we can have the exception for 0 division error, and then we can print here that dividing by 0 is also not allowed in my own divide function. Another way to make sure that your arguments passed to a function actually of the type that you want or the values that you want is to make sure of the assert word. So if you have here print a function that's called print string, so obviously we just want strings to be passed to this function. So here we could assert that string is not none, so if it doesn't have a type, or assert string not equal to nothing. So if there is nothing past this function, we throw an error. So now we could print print string hello, but this one will not need. So this here works, whereas if we pass an empty string, then it will throw an assertion error. So like in the above example, now we'll then have to have a try function outside of this function to catch the assert error that is given. So one of the last concepts I want to go through here in this basic Python is the concept of classes. So let's start out by creating our own class. So let's call this class for a person. Now we have the constructor for person, well, for any class being created. It's in the function called underscore underscore init underscore underscore. So maybe we pass name and age to this function, and then we assign the name to the self name, so the name variable of the person class, or the person object once it's created, and the same with the age here, like this here. So now we have the basic functionality. We have a class and we have some kind of constructor. So now we can go in and say, okay, person1, person is called Adam, and he's 30 years old. So what can we do with this now? Well, we can look at, okay, person, he has a name, so the name variable is available to us. So we can try to remove this line here. What if we do not assign it to self name? Then it does not have the attribute name. So let's take this back here. And as a continuation of this, like, we can also change, for instance, the age here. Oops. So after creating the person1 object from the class person, we reassign the value of age to 25. Okay, let's look at some other things we can do with classes. So we could, for instance, have our own print name age function. So it could be that name. So here in the start, we'll have to have f. And now instead of calling person1.name and formatting down here, whenever we want some information about this person, then we can just put print name age, and then it'll nicely be formatted for us. And then it'll be nicely formatted for us. As you might have noticed, the init function has these two underscores, and we can make another function like that. So the double underscore is there to symbolize that this is a private function. So we just have a function here that will return the age of the person in days. So kind of approximate. So now we'll just see, is this function actually private? So it turns out that it's actually not private. So we can still call it from outside, but the idea behind the double underscores is that you should never call these functions from outside. Instead, what we should do is to have another function which will be called age in days. And this function can then return whatever is in, so instead of return, we could print age in days. And so now instead of calling this private function, we'll call print age in days. And let's create a few additional functions. So is adult, return if age is above 18. And then let's have a function that this person can marry. Let's say another person, and here we can again make use of the search functionality. So we'll have to see if the adult that wants to, so we'll have to look at if the person that wants to marry another is adult, and also that the partner is an adult person. And if you're marrying someone, then we'll put an object of that other person in the self-partner variable. And maybe we can also have a print function here saying that name is now married to so now instead of this print name age, so now we can make a person 2 Petra. Petra is 35, and we can have that person 1 is marrying person 2, and the same thing that person 2 is marrying person 1. And now write that Adam is now married to Petra, and Petra is now married to Adam. Just like we have the private functions, we can also have private variables. So the first level is protected variables, which are defined by a single underscore. So maybe we have a value here that the salary of a person, we not want anyone just to use that from outside the function. But as with the private function, actually we can do this. So here we can say person 1 salary, and we can even set another value to this person 1 salary variable. So instead, if we would like something not to be available to the outside, we have to use a double underscore. So double underscore, and then we could have if this person is a criminal, and now we can then see, can we access criminal? So once we use the double underscore, this will not be visible outside of the class itself. Now we have similar classes, then we can also look at, okay, how can we actually have some kind of successor of a class. So what we now do is look at inheritance, like how we inherit a class from another class. So here, for instance, we'll have the class child, and might inherit everything from person. What we can do here is we can define again the constructor. We'll have self, name, age, just like in the person constructor, mother, father. And now instead of writing all the same functionality as in the other constructor, we can make use of the person constructor. So here, child, self. And then we can say that mother is to mother and father equal to father. Something like that. And now we can then create an instance of this. So maybe there's a child, and he is called Alex, 7 years old. He has person 2 as the mother and person 1 as the father. So now if we have child dot mother dot print name age, we should be able to print the name and the age of the mother. And maybe we just want to make one additional function here. So if parents are married, return self-father partner here is equal to the mother, and self-mother.partner is equal to self.father. And then see child.parents married. And it'll return true here. So one of the powers of Python is really that it has a lot of packages which you can easily install just by a conda or pip install and then the name of the package. For instance, we can look at the built-in module. It's called platform. So if we import platform, now we can look at, okay, what kind of functionality does platform have? Like what functions can you actually call in there? So you can call Python build, processor, platform, OS. So in our case, okay, let's look at what is it actually for a processor we're using. So this way, using dir, you can figure out what are all the functions that I can actually call. If you want more information about a specific package, you can also instead use help, which is then give the full module reference. And as I said, there are a lot of more packages available. The only thing you need to do is use conda install and package name or pip install if you prefer to use pip. So all the basic Python functionality you can find at W3 Schools. And this notebook is also available at my GitHub repository, madsanddennis/notebooks. And on that note, thank you for watching.